Hello and welcome to World Festival 2021. It is my pleasure to introduce our next speaker, Mr. Filip Babić. He is the lead Android developer for Jetpack Compose at Stream. He'll now be joining on screen. Thank you.
And hello, everyone. Thanks for joining. So this talk is about Jetpack Compose, as you know. It's actually about the product that we've been building here at Stream. And as you know, I'm the lead Android developer for Jetpack Compose at Stream. If you want to know a bit more about me, you can look me up on, well, I guess the Stream website. You can look up what I do. You can look me up on Twitter and LinkedIn. And we'll kind of be able to chat a bit more after the presentation itself. Because we have a Stream timeline, I'll just kind of jump into it. So what I'll talk about today is a few things, actually. So initially, why we chose to use Jetpack Compose to build a completely new chat SDK here at Stream, how we dealt with the API stability, what we saw from the Compose itself, like is it stable enough, is it not, how has it evolved in the past few months or the past year. I'll talk about the common pitfalls, so some of the things you might want to avoid or some of the things you might want to look into when you're building something new with Compose. And finally, I'll talk about some of the more specific things about our SDK, such as the design system that we decided to build or to use, the flag hierarchy approach, and finally, the customization mindset that we provide with our components. So initially, you want to ask, I guess, and this is one of the most common question is, why did you use Jetpack Compose for something new? Especially because we started building this SDK a couple of months ago, so back before Compose was stable. So yeah, we wanted to explore something new. We wanted to jump into Compose because we knew that it was going to be a very promising thing in the Android world. Essentially, everyone was talking about it like it was going to be something that's completely game-changing, and I think it actually will be. Just give it time. One of the things that go with that line is that Compose is very fast and very efficient when it comes to development. So it's very easy to build some things in Compose, or more easy compared to the traditional way of using XML, using multiple files, using different types of Android view components. But it's also very intuitive. So the API design is very intuitive when you get past the initial learning curve, because when you take declarative programming in mind, which is something that Compose does, when you combine it with things like MVVM and all the cool Jetpack things that we've been using for years now, and when you take components or UI components as functions, you get to this state where you can write really deeply customizable code, and you do all this in a single language, which is Kotlin, instead of combining XML and Kotlin or Java even. So because Compose is kind of tied to Kotlin, this means that you have this, I guess, type of situation where you have to use Kotlin, but at the same time, you only have to use Kotlin, nothing else, more or less. So because we decided to jump into this very early on, so as I mentioned a few months ago or a couple of months ago, before Compose was stable, you probably want to know a bit about stability. And for the most part, at least for me, I think Compose has been stable for months now. So since the actual first beta versions, I think the core API has been very stable, very secure, very easy to use. There have been some parts that have been changed, such as the animations API. There are some experimental APIs currently in your day-to-day work, such as permission API, the grid API, and some of the material or foundational APIs, such as modifiers and click listeners and so on. There are some things that are not very stable yet, or that might be prone to change. But for the most part, the fundamentals themselves are very, very stable and are not changing that rapidly. So you could essentially, and because it's like 1.0 now, you could use it for most of the use cases you're going to build in your applications. So some of the things, as I mentioned, that you might want to watch out for are Accompanies tools. So these are Accompanies libraries that are here to help you write Compose code and build some features in Compose. Most of these tools are targeted for Compose, and they are being very heavily developed, or very frequently they release with new things, new improvements. So some of these libraries are developed in the experimental phase right now, or beta phase. But as soon as they're stable enough, you can just pull them out as stable components and use them in your applications. And as I mentioned, some things like modifiers, like the grid API, the material components such as the surface with its overloads, those APIs are currently marked as experimental, but you can still use them. And in case they change, you have alternatives which are not experimental, which you can work around with. So kind of to sum it up, I think Compose is very, very awesome. It's really easy to work with and really easy to develop features with. And we managed to build, fully fledged, I guess, Chat SDK in a couple of months, which is really awesome, really cool. So it's both really well developed and really easy to use, but it's very, very stable as well, because we managed to build a really rich set of features just in a few months, as I mentioned. So with that in mind, how did we actually design the components that we have? So, excuse me. So we have three components actually, or three types of components that we provide in our SDK, the Jetpack Compose SDK. So we have first and foremost screen components, which are out-of-the-box solutions that don't offer too much customization, or they have limited customization, but at the same time they allow you to build rich chat experiences very easily with just a few lines of code, or just one line of code as it were. And it gives you an entire screen that you can use. It's really good for showcases. It's really good when you want to test the API and see what it supports, what it doesn't. If you have like a very simple use case that doesn't really require a lot of customization, for example, like chat services for the support side of your application, that doesn't really tend to be very custom, so you can do something like that very easily with screen components. If you're looking for a bit more customization and you want to combine multiple components, we have bound components, which are components that are bound to our view models. So these are, again, out-of-the-box solutions, but for a portion of the screen, which makes them much more customizable, as you can just focus on that part of the screen, but you can also combine them with other components, which lets you build completely custom UI. We'll kind of go through this in a moment. And finally, what bound components use underneath are stateless components, which are components that are state-driven. So they don't produce or remember any state themselves. They just get state from the outside. And they offer full customization. So customization in terms of the, let's say, the very basic styling of the component, customization in terms of overriding behavior of component, and the state itself, because you have to provide the state for them. And finally, customization in a way that you can override certain parts of those components, and we'll see that in a moment. So screen components, as I mentioned, are very simple to use, very easy. They give you rich experience without a lot of trouble. So for example, here on the left-hand side, we have the messages screen, which is the central part of any chat application. So you have a conversation, you have some messages, you have users in the conversation. You can go through the messages, like scroll through them. There's lazy loading. You can send new messages and send attachments and so on and so forth. So there's a lot of interaction here. As I mentioned, a rich set of experience. Now, to integrate this component, as you can see on the right-hand side, you only have to pass in a few parameters or just write a few lines of code. So essentially, this messages screen component is very complex. It builds the entire experience for you, so you can see what it looks like without having to do a lot of setup work. As I mentioned, this is really good if you have very simple use cases where you want to keep the default experience or behavior, so to say, but you can still customize these components through our theming options, which I'll get around to a bit later. As I mentioned, these components are very simple. They usually have just a few parameters. The important parameter here for the message screen is the channel ID. So you have to provide the conversation ID that you want to show, so the messages where you want to load them. The rest are pretty much almost always defined as default values, which is the default behavior. So the header action might not do anything. You might get like a default backpress action if you want. And we show the header by default. So you might want to hide the header if your use case entails that. But for the most part, you can just use this to test and play around with the API before actually diving into the customization. The next level of components, or the next type of components, are bound components, as I mentioned. So on the left-hand side, again, you see a portion of that messages screen. where you just see the message list. So just the list of messages without the composer or the input field, and without the header where you can see more information. So again, on the right-hand side, you can see the integration of this component. So you can just put it in with the rest of your UI. So for example, in the setContent function. And you can only need to pass in a few parameters to make it work. It still has the entire rich experience of the messages list, which is showing messages, being able to select messages, being able to enter threads, preview images, or show different types of attachments. All of this exists, but in a very small manner, so to say, so a very specific manner, just for the messages list. So this allows you to essentially take this component and build a completely custom input field if you need that for your use case, or a completely custom header if you also need that. So these components obviously exist in a few different ways. So you have the composer or the input field as a bound component, you have the message list and the header. And you can combine these three components to essentially in any way you want, or you can use your own. The bound components have a few more parameters. What's really important is that you pass in the model. So as I mentioned, they are bound to a view model. In this case, for messages list, you have to provide an instance of this. But for some components that are very simple, that we can provide a default view model for you, we do that. So you don't even have to essentially provide any parameters to the component. The rest of the components are used for customization. So for example, we expose a few actions that you can take with the message list, such as what happens when you click on a thread or a message in the list, what happens when you long click on an item, when you reach the start of the list to trigger lazy loading, or the bottom of the list where we update the message state so that we know that there are no new messages that you haven't read. So we expose these components by default, but you can also customize them if you want to override the behavior. And finally, we allow this way to override different types of content parameters. So for example, in the message list, we have the item content parameter, which governs how each of the messages looks. It's applied to each message item in the list, and it essentially renders the list of items as you've seen on the previous screen. So in this case, you can use the default container for the messages, which generates all the information you might need or you have seen currently, or sorry, previously on the screen. But you can also completely override this message container to your liking. So you can build something like a more Slack clone version of the app, something that's more closer to, let's say, WhatsApp or Telegram or something else. So to this extent, it's very customizable. And finally, the stateless components that are, let's say, fully customizable are some of, so we have two examples here. So we have the search input, which is the component that you can see at the top, which is a very simple, very straightforward component that allows you to search something, such as query channels by name. And we have the channel avatar, which is a more, it's a very simple component, but it does some complex internal works where it renders, avatars of users, active users in the channel. So again, these components are very simple. They are stateless because they don't rely on any view models to load their state. You have to pass in the state, and you have to pass in the actions that are taken when something changes, such as the query in the search input field, or if we have some buttons or something like that, what happens when you click on that button. As you can see, the avatar is very simple. Again, it requires a channel to load the information from the channel, and also the current user, so we know that which images from users we have to render. So we don't render your image if you're in the channel with 3 or 4 other people. So those are the important components. That's essentially the only thing that you need to provide. That's the state that is being rendered. The rest of the parameters are used for customization, such as the content description for accessibility and the modifier for the look and feel of the component. So that's kind of how we built these components and what our design style is. Now let's talk about some of the common pitfalls that we've encountered and that you'll probably encounter when you dive into Compose. The first, which is very common, which is thinking imperatively. So in Compose, you can't fetch a reference to a view. You can't store a view somewhere in a variable and call, any functions to update the state, such as set text or something like that, or set any listeners. So that's not something that happens in Compose. In Compose, you have to work declaratively, and this means that you have to basically create everything ahead of time, define all the behavior that might be important for the components, and also define all the states that might be important for these components. That's like the very, very basic part of Compose, and it's something that you'll probably run into until you get the hang of the initial learning curve. The second big pitfall, I guess, is hard-coding customization. So we still kind of do this, or like we've had some issues where we provided some components and we put in some of the basic customization in our modifiers, which made sense at the time, but then we realized that like using specific modifiers in internal code essentially means that if the user wanted to override that modifier, they couldn't do it. So the idea here is, again, to allow the user to customize everything through modifiers if they want, and only use the very, very basic or very, let's say, common behavior for your components that has or can be hard-coded, such as the shape of your, let's say, message bubbles, or the shape of your avatar, or something like that, or maybe the colors for your components that you provide by default. These are okay to hard code, or let's say hard code, but anything that's going to be customly built by the user, so they're going to customize it, you should think about not hard coding everything. The last two examples are not very specific to what we ran into, but this is more of a just a sanity check when you start working with Compose and you start building new things. So again, just like when Kotlin became first class in Android and everyone wanted to like migrate to Kotlin as soon as possible, you should migrate slowly. So essentially, try not to rush things, try not to do everything at the same time. Pick a few small components that you want to build in Compose, maybe a new screen that you have to build. So why not just do it in Compose first and see how it goes? That's a very good starting point. And after that, you can go into this depths of recreating screens in Compose and then replacing the XML based views with Compose. That's kind of the approach I would take, and essentially that's something that I did with my personal projects before I joined Stream. The other issue or pitfall is that there is a lack of examples currently. So there's not a lot of information out there to guide you. There are some books, obviously. There are some sample projects. There are some libraries out there, such as ours, that use Compose. But this doesn't mean that any of these pieces of code are the best way to build Compose or the way to build Compose, right? Try experimenting with it, just like we have for the chat SDK, and try seeing what works for you and what helps you or makes it very easy for you to build your use cases. For us, it was this design system of 3 types of components. We now have like a clear structure of what goes where, or how do we design these components. Based on users' feedback, we're going to probably improve that or maybe change that or in the future, but we have to see. Yeah, our Compose code is perfect, yeah. But for the most part, if you're building something new with a new framework like this, try not to be as influenced by other people and other examples. Obviously, there are some very, very clear things that are good out there, and I'll share that in the resources in a moment. But before that, let's talk about 2 really big things, such as I mentioned, so the flat hierarchy approach that we take, and also the customization approach that we take in our code. So a lot of examples of other declarative frameworks, such as React Native or React on the web, or Flutter even. I've seen people dive into this pattern where you have deep component nesting, where you have a root component that has some children, and then those children have other children, and so on and so forth, because you need to propagate and it's usually called like the context or the information from the parent to the child. This is usually very useful, and you can send a lot of information without having to use different types of, or a different number of parameters, like 10, 20, 30 parameters in every component. But what I'd suggest for you to do is move to a more flat structure in Compose, and logically decoupling these components so that you know what components are used, let's say, for the messages list, for showing overlays to the user, for showing more information, such as having pop-ups or dialogues, and so on. And once you get this flat structure, which I'll show in a moment, try thinking about what information you need for each of those components, and try to make the information available in a flat or a horizontal structure, instead of having deep nesting where you have to send everything to every single component. So for example, in our messages screen, let's kind of take away some of the business logic and everything that we have here, or preparing the state. We have a box which essentially fills the entire screen. We have a scaffold within it, which shows three components, three of the most important components. So the message list header, the composer for the bottom bar, and the message list within them as the content. What we have after that is, because we're in a box, we have this flat structure where you can show anything as an overlay. So we have a few checks actually, which represent different types of state. So the selected message state, or the selected message being not null, means that we need to show the selected message overlay. So when users long taps on a message, and we need to show them some options. The same goes for attachments. So if we are showing the attachments currently, then we render the attachment speaker component. And finally, if there is a delete action within our message actions currently, that means that we want to delete a message. So we show a simple dialog with that message. Obviously, some of the code has been omitted here because it wouldn't fit on the screen. But you get the general gist of it. And just with that flat structure where we have one baseline component, such as a scaffold, and a few components that are shown based on different checks, we can achieve this behavior where we have the attachment speaker that shows some attachments, and it essentially lets you perform a few actions to get your attachments into the message that you're going to send. We have the selected message overlay, which essentially allows you to do a few different actions on the message, such as showing a or sending a reaction, replying to the message, opening a thread, copying the message, muting the user, and so on. And finally, we have this dialog pop-up, which is a very simple dialog that essentially gives you the option to delete the message if you want, if you own that message. So all of these three components, even though the interactions between them might be complex, the state might be different based on these, or when these components should show, they all live in the same level, as you can see here on this line, which makes it really easy to observe what state you can use to show different components, what components show and when. Instead of having very deep nested states, such as using this attachment picker as a bottom bar, which you can obviously do, but that means that you have to wrap the bottom bar in, or so wrap the content in the bottom bar that you're going to show, which is not always ideal. And to avoid all this nesting and all this crazy structure, you can just place everything in a flat structure, and it makes it easier to reason about the code. And finally, I want to talk about the customization mindset which we have. And there's just a few points here. So the customization that you can provide always is providing true modifiers, like having a single root modifier for your root component, or having item modifiers if you have a list of items or something like that. This guideline is actually from the Jetpack Compose API guideline, which is the official guideline from Google. And you should always follow it. So that's all, or follow it for the most part where you know that the component is going to be customized. Again, as I mentioned, try to avoid hard-coded modifiers unless you're building something that's self-contained, so something that's not going to change based on the user's need, such as the screen components. And try thinking about theming options and providing a very concrete design system, as well as content function parameters, so you can override certain parts of the API or certain parts of the component that you show. So here again, for the messages screen, we don't expose too much, but for the composer, we do. So the composer has three groups of customization, I guess. The first is the very basic. So where does the state come from? And what does the root component look like? The second is the actual actions that we can override to control the behavior of the component. And finally, we have three Lambda function parameters, which define what the integrations or the leading actions are, what the label for the composer is for the input field, and what the actual input field is if users want to override that. So you can override the complete input field, the integrations at the start, or just the label. By default, everything is going to work, but you can still have this customization option available. And finally, we have this chat theme, which is a very powerful way of customizing our components. Essentially, we provide a certain set of state that you can apply to all of your components in your hierarchy. So just like we said, like the React or Flutter way, you have a certain context that's applied to every single child underneath, and it's accessible from anywhere. And for example, here in the colors, what we do is we built custom stream colors that are very specific for our design style and are applied in very specific spots in our SDK. So you can customize these colors, and it's going to reflect across the entire application without actually having to manually point to each component where you want to use these colors. This is all predefined for you. So some of the resources, and I know I'm kind of over time. So you can obviously check out our SDK, which is really, really well documented, I think, and we have a ton of documentation coming still. You can check out the tutorial itself, and you can check out the repository that we have. So you can browse the SDK, you can play around with the sample apps. There are also some of the other guidelines or tutorials that you can use, such as the Google side of documentation. So the guidelines for the API design or code labs and tutorials that you can do. And I also put in here 2 talks that I gave about an introduction to Compose and some advanced bits. So these talks are a bit out of date because I gave them like 5 or 6 months ago, but they still give you the fundamentals and the very important information. So even though the syntax is out of date, it's still valid information if you want to check it out. So thank you for listening. And if we have any questions, I think we're over time in the main session, but you can always join us, as Kimi mentioned, you can join us in the Q&A booth for stream afterwards. And I'll jump there in a moment, and we can discuss more questions there. And well, I guess help you realize what we did with Compose and how we did it. So thank you.